Hello, and welcome to this evening's TI Technology webinar hosted by Texas Instruments, where just in time for Halloween, we'll take a look at what superheroes, zombies, and forensics have in common. I see that many of you are joining us for the first time, so we'd like to offer a special welcome if this is your first T-Cubed Professional Development webinar. We'd also like to thank everyone for completing the live survey on the right side of your screen. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm very happy to introduce our two panelists tonight, Mike Cimino and Jeff Lukens. Mike is an 8th grade science teacher at Heritage Middle School in Deltona, Florida, and has been teaching for 8 years. Mike is a science department chair at his school and teaches a variety of levels, including co-taught, AVID, Gen Ed, Advanced and Gifted Science. Along with teaching, Mike is also the district contact for Science Olympiad and is involved with numerous other district and national activities, including SOPHIA, curriculum mapping, STEM integration, and assessment writing. Lastly, Mike was also named the Volusia County Schools PRISM Science Teacher of the Year in 2012. Thanks for being with us, Mike.
Thank you, Mike, for having me tonight. Really looking forward to a great evening.
And when Jeff retired from teaching in 2014, he was teaching high school science for 34 years. He currently delivers professional development across North America for the Teachers Teaching with Technology organization and as a full-time science instructor. He continues to author activities for all levels of science teachers and learners. Thanks for being with us, Jeff.
Great to be here, Mike. Thank you.
We're expecting a large crowd, so your audio is automatically muted. Feel free to send any questions to all panelists using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. Once we move to the teacher software, that right section of your screen will be replaced with a green floating toolbar. Again, you can access the Q&A window by clicking the question icon. This session is being recorded, and as a reminder, we'll provide the link to the event certificate of attendance at the conclusion of the webinar. Once that recording is available, if you'd like to follow along with your handheld or software, and we do hope you will, we recommend doing this with the recording. That way you can download the activities and then pause and rewind the recording as necessary. We don't expect you to have any audio issues tonight, but in the event that you do, try selecting Communicate in the WebEx menu, choose Audio Broadcast, and then click Join. At this point, Jeff is going to discuss our agenda.
All right, Mike, thanks. Good evening, everybody. And Mike just went through the welcome and all the introductions and some of the logistics about being on your end of the webinar. And what we're going to do tonight is take a look at what we have called a TI the STEM Behind Hollywood program. We think it's been wildly successful. We started off with a zombie apocalypse activity a little over a year ago, and we have since added several activities to that, some of which you're going to see this evening. The ones that we're going to take a look at, and I'll tell you a little bit about the whole idea behind the STEM Behind Hollywood effort. Mike Cimino is going to take us through, I think it's our newest STEM Behind Hollywood activity called Science Friction, which I thought was quite a cute name. And then we're going to give a brief description and have a brief look at the thing that started it all, which was zombie apocalypse. And then we're going to move on to Zombie Apocalypse 2, which is the newest of the newer, I should say, of the zombie activities. And then actually it looks like we're going to wrap up with body of evidence, but we're going to, if you could kind of visually take that body of evidence one and just slide it right up above between Science Friction and Zombie Apocalypse. We're just going to move that one into the second slot in the batting order tonight. And the whole idea behind the STEM Behind Hollywood program was to take themes that young people would relate to it's a little frightening to think they might relate to zombies, but they certainly have been interested in them. Zombies, superheroes, forensics, that type of thing, and make activities that would be interesting to kids, and then sneak in some science and some math, and not just the STEM idea, but perhaps the entire, and I know in some parts of the country, STEAM, stick an A in there, S-T-E-A-M for the arts, has been a movement as well in addition to STEM. So we're hoping that this evening you'll get a glimpse of the idea behind these activities and see how easy they are to use on virtually any platform that you have. And when I say platform, I'm talking about the handhelds, TI Nspire handheld, the iPad. There's a TI Nspire app for the iPad, the computer software, which also will run these, and any of those can run the activities we're going to be looking at tonight. And then once we get through all these activities, and we're ambitious, we're going to try to do 4 in a fairly short time and give you an overview of them. Mike Houston will wrap it up with some free online resources that you can access from the TI website.
Thanks, Jeff. And Mike is going to discuss our expected outcomes.
All right, thank you, Michael. We are going to explore activities today that let students play a villain's henchman to explore force, friction, rate, and Newton's third law of motion. We're also going to investigate the hypothesis that elevating pH could prevent people from becoming undead. We are going to use some interactive data plots from a simulated death investigation to establish the victim's identity, and we are going to stay in touch with social media and upcoming events. It really goes quite well from the expected outcomes with Halloween right around the corner. So we're actually going... Yep.
All yours.
All right. So we're actually going to move on to the first activity tonight, which is science friction. And as Jeff said earlier, this is the newest of the STEM Behind Hollywood activities. With this activity, students are going to investigate friction, and along with all of the forces that interact within friction. So friction is a force that opposes motion when two objects are in contact with one another. It depends on the texture of both surfaces. And that's really what this investigation is going to look at. We're going to look at the coefficient of friction of various surfaces and how that could have an effect on a plot between a superhero and a villain. The one thing I really love about this activity is that it sort of scaffolds the information for the students. So even if your students have a lower level of introductory knowledge, this simulation can build upon even the most basic levels of knowledge and guide them through the activity. And of course, with the investigation being a superhero and a villain, it's going to lead to higher levels of engagement for your students. So there's a lot of visuals in this as well. So on the screen right now, you're looking at a basic visual of the different forces that are acting on a block. Students are going to use that image as they progress through the simulation to further investigate what is going on in this plot. So there's some background information for the students to go through and read. And then eventually we have them recall some information here. So after they get done reading, we have a basic introductory question: what is force? Continues to go on to talk about Newton's second law of motion. And we get to this page right here. This is where the students actually have to start doing something. So on the left-hand side of my screen here, underneath my documents toolbox, I'm actually going to bring up the calculator. So you'll see the handheld image up on the left-hand side of the screen. And this over here on the right-hand side of the screen is what the students would see on their TI Nspire handheld. Now you'll notice the screen is broken down into two sections. You have the section on the left here, and you have the section on the right over here. One thing I really like about this section on the right is that this is where the students can actually do some of their calculations. So the question here is if the object on page 1.8 has a mass of 1.02 kilograms, what is the acceleration in meters per second? So this would have the students go back to page 1.8, look at the overall force in the image. We can go back to 1.10 and actually solve for it. So I'm going to do my work here on the right-hand side of the screen. And I'm just going to type, assuming this is your handheld over here, I'm going to type in 1.02. And I'm going to multiply it by 10, which was the force. And I get an answer of 10.2. I can then go over here and enter in my answer. So it's just a simple way for the students to be able to do their calculations on the same screen as having the question. So it's sort of almost like one-stop shopping here for them. The simulation continues looking at Newton's second law. And it provides, I love the color in this. Again, it provides a visual representation of the data. And there actually is a question to go along with this. So question 3, what is the mass of the cart from page 1.12? So it's sort of a multi-step question here where the students are going to have to go back, look at the data. And using Newton's second law, we know that the force here is 0.23 newtons. The acceleration is 0.34. And again, the students can, and once they do the math, the students can enter in their answer right over here in the answer box. And you'll notice all of this here, it's a little bit of background information so the students can get prepared to go into the actual crux of the simulation and be able to do the activities later on. And again, this here, I absolutely love having the calculator on the right-hand side, allowing, so if you're a math teacher and you want to see the student's thought process, instead of just getting an answer on the left-hand side of the screen, you're actually able to see where the students may have made an error as they're going through and they're answering the question. So this is where it starts to get really interesting. Now that we're done with all the background information and the students have an idea of what friction is, how Newton's laws have an effect on friction, now we can start to look at the story. And that's one thing I love about all of these STEM behind Hollywood activities. They all have a story to go along with the simulation. So it really gets the students involved. And with this one, we actually have some characters to go along with it. So in here we have a hero. And of course, the hero is always prepared to save the day. And the hero never fails to call, never fails to call for help. They always show up just in time. And you'll see then we have the villain. And the villain is the civil engineer who formerly led the highway engineering in the city's public works department. The villain's job and responsibilities included planning, construction, operation, maintenance of roads. So you have your two different characters here. You have your hero and you have the villain, who pretty much didn't get along too well with the public works department. It moves on to give us a scenario. So there's this new bridge that's trying to be under construction, and the villain is not happy. The villain does not want this bridge to go through. He was fired from his job. He's got a lot of anger built up, a lot of emotional issues along with the bridge. So the villain has an idea. He knows that superhero. He's going to swoop in just in time to try to save the day. He's trying to think a step ahead. What can he do to try to stop that hero from saving the day? And that's sort of kind of puts you into the villain's shoes here. So you have now, it's a little bit of a role reversal. Typically, you're always going to try to be the hero in most situations, but not now. You're the villain, and you're trying to figure out how can you stop that hero from getting to the bridge in time. So he's given you a special tool belt loaded with a water gun, an oil gun, and an ice ray. And what he wants you to do is you need to find a specific spot along that route, and we need to figure out how we can stop the hero from getting there in time. So we have a couple of visuals. There's three things we're looking at: the water vial, the freeze ray, and the oil can. Which one of these three can we use to stop the hero? So first, students are going to generate a hypothesis. Which one of these three do they think would be best at stopping the hero? Now, as Mike and Jeff were saying earlier, these simulations work across a plethora of platforms. You can use these on the iPad, you can use these on the handhelds, you can use these on the teacher software with the computer. And this here, as you can see, there's different ways that you can input that information, and the instructions are on the screen. So if I'm on the iPad, I just have to tap the screen to go through each one of these. If I'm on the TI Nspire, I can just click right on the screen. It's going to go through, and it's going to show me all the different scenarios with that hero. You can see him slipping on the water, really falling hard on ice, and slipping, sliding all over the oil. We're going to move on to the next page, 2.11. This is where students try to come up with a reason as to why they think the hero slipped and fell when they sprayed the concrete with the oil and ice ray. Now that they have some predictions, we're going to move on a little bit more now into actually looking at the math here, looking at the coefficient of friction. So the students are provided with the coefficient of friction for dry concrete, wet concrete, and ice, with material 1 being rubber, of course being the hero suit. They're going to rank them in order. And then they're going to do a little bit of math here. So question 13 asking them, if the hero has a mass of 90 kilograms, we need to find the maximum static friction for the force for dry concrete. So we're going to use that information from page 2.14, and the students are going to find their answer. And this is great because it's a two-part question. The students at first have to find a normal force, and then after that, they're going to take into consideration the coefficient of friction. Students will continue to do this with the ice surface as well. They'll then investigate, how does Newton's third law apply to an individual running on a surface? They'll explain why friction is necessary for the hero to be able to walk or run. And then they need to determine, using their tool belt, what's going to be best. Is it going to be the ice ray? Is it going to be the water? Or will it be the oil? And can you think of a strategy the hero could use to defeat the oil or ice? What could they do? What could the hero do to try to defeat that and get past it and save the day? And that, ladies and gentlemen, is science friction. Jeff, do you have anything you'd like to add?
No, that's pretty cool. I like that hero and villain thing. And you know, as you were talking about that, Mike, that can be sort of a theme that runs throughout most of the STEM Beyond Hollywood activities, which makes some sense because in any good movie, you're going to have protagonists and antagonists and whatever else those literary and movie kind of descriptors are. So it's kind of you'll see some commonalities running through all of these activities with good guys, bad guys, and so on.
Yeah, I really like how you play the role of the villain in this case. So it's a little bit of a different, interesting twist on the simulation, where instead of being the hero to save the day, you're actually trying to be the villain to stop the hero from being able to save it, which I thought was pretty cool.
Hey, Mike?
Yes.
So Kathy had a question. You guys were asking, or at least there were some really great questions built into that activity, the science friction.
Yes.
And she wanted to know if the teacher was able to see those student responses.
Oh, definitely. If you have a TI Nspire navigator system, you could, all of these questions that are embedded into the simulation, there's a couple things you can do. You can use class presenter feature, and you could actually view not one individual student handheld and have it displayed on the screen in real time, or you could actually view your entire class all at the same time. So that's one route that you could go if you want to see question by question. But then we also have another great feature where you can collect that file, and it will, the system, the TI Nspire Navigator system, will automatically grade those responses for you. And it will show up, if you look at the top of my screen here, I have a little review and portfolio tab, and this is with the Navigator system. It will actually grade those, and you can review all of those responses in your portfolio. So anytime you see one of those questions, like this ABC, the normal force, force of gravity, coefficient of friction, when the student responds, it will be saved. And that's why we have over here on the left-hand side of the screen, you'll notice under my Documents toolbox, I clicked on the little wrench icon here, and you'll see coefficient of friction was selected as the correct answer. And it will automatically grade those for you with the Navigator system. It's one of the great features of Navigator, and it's something I use in my classroom every single day.
So, Mike, one more quick question. What if you don't have Navigator? What can you do so you can still use the activity and also see what's going on with your students? What do they know?
Oh, we could still even, if you have the teacher software, you could always even collect it with if you have a USB wire, you can hook the handheld up directly to the computer with the teacher software up to the USB wire, and you can save and see the students' work on there as well.
Yeah, the other thing I was thinking is that also with the student activity that goes along with this, the Word document.
That as well, yes.
Right. So these questions are all also embedded into just a printable PDF file that you can print out and use with your students. And so if you don't happen to have the Nspire Navigator system, or you're not familiar with like collecting some of those files, you can still just have them just jot down their thoughts, and you can collect it and view it yourself later.
Yeah, thanks for reminding me, Mike. Definitely. I have the file pulled up on the screen right now, the PDF. This is the actual student activity sheet. And everything that's in the simulation is also on this page right here. And sometimes the kids do like having that paper copy in front of them as well. And that's provided for you here.
Thanks, Mike.
All right. Jeff, did you want to show some body of evidence?
Yes, I would love to show some body of evidence. Sure. You don't know how close I came to saying something I shouldn't, probably, right there. All right. So Mike just showed you guys the newest and coolest, most recent coolest anyway, STEM Beyond Hollywood activity, which is science friction. Here's one that deals with forensics. We developed this activity probably 8 or 9 months ago with the help of an actual forensics anthropologist named Diane France. Dr. Diane France is a lady who does work for several law enforcement organizations in Colorado. And she was our advisor and our technical person on this activity. And essentially, and like Mike said, all of these activities, we try to start it with, on the very first page, something that's going to kind of catch the attention of the students, whether it's a cartoon superhero or this clearly dead person sitting lying here behind some crime scene tape. Love this. I mean, I didn't even notice this the first time. STEM scene, do not cross. I think that's so cool. And one of the things that we kind of sneak in on the kids when we do these STEM Beyond Hollywood activities is a little bit of background information that we sort of frame in the form of a story, like you saw with science friction. Same thing is true here. We have a dead body that's been discovered, and there's some background information that deals with, kind of sneaks in some STEM career opportunities for kids here. So let's take a look at some of these. You are actually playing the role of a forensics anthropologist, so having Dr. France as our advisor on this activity was very appropriate. And so this is kind of a little background information. You find the body, tells you the weather conditions, the body is kind of smelly, there's maggots on it and so on, which is not pleasant, but you know, if you're 14, 15, 16 years old, maybe that's sort of exciting. And at least gives a little background information that the kids are asked to read. So we bring in a little more background, and then we start talking about, we throw a few questions out at kids that deal with certain occupations. And again, here's that sneaky part of these STEM Beyond Hollywood activities. We bring up this forensics anthropologist and pathologist and entomologist And those are really, really big words, but all three of them have some things in common as far as the root words that make them up. And so we talk about those a little bit. Then we have a dialogue between the police officer. The you here is the forensics anthropologist, the role the student is playing. And then we have a pathologist, which is a disease studying physician, essentially. And so a lot of these background information, looks like a lot of text, but we try to make it as interesting and as engaging as possible. This is one that kids really don't blow by. They get to this page and they sit there on this one for quite a while trying to let their imagination run wild. The 5 stages of decomposition of a dead body, and whether that body is human, which is in the case of this activity, or a raccoon on the side of the road, Dr. Francis assured us that all of these 5 stages are actually sequential in terms of the decomposition of a dead body. So we finish up with a little dialogue, a little text conversation between you, the anthropologist, and the physician. Then on the next page, we have a picture of the 4 potential victims that we can't identify the body necessarily by the face anymore. Clearly, these 4 guys are very distinguishable with their face. I was hoping actually to get Rob Wilson in here and Stacy Thibodeau and Greg Williams, Curtis Crossley, people like that, but we had to settle for people that actually work at TI, that's who these people are, with made-up names. So there's our 4 potential victims. By the way, keep an eye on this guy right here, Cy Walker. Okay, I'm going to give you a second. Tick-tock, tick-tock. Take a look at that little guy's face. Okay, I'm going to move on. Just as in with science friction, there are questions embedded throughout this activity. And by the way, just a little something about question genre here. Notice the question says check all that may also play a role, etc. When you make these questions and include them and embed them in an activity, you can actually, one of the criteria you can put in there is allow for multiple answers. And so that changes the bubble to a box. And that may take a little bit of instruction on the part of the teacher for the kid to know that, but I think check all that may play a role should be fairly self-evident. Okay, when we get to this point, page 1.12, we're on the verge of actually seeing a body going through an animated decomposition. Now here we have clearly a body, and here we have 2 different sets of environmental conditions. So we have a temperature and then a humidity. Okay, so what I'm going to do is just show you a couple of these different variables. And so let's make a cool and humid environment. And by the way, check this out. Cold, look at that background, dark blue, like burr, cold. I'm from South Dakota, so I don't like to see that in October because that's coming. Cool, not quite so much. Warm, oh yeah, cool, orange. And then we get down to where Mike lives in Florida, and it's hot and humid all the time. So we'll say cool and humid. And then just like with YouTube or whatever, all of our animations have a little green play button that the kid can click on. And I'm going to go ahead and play this and just watch up in this area, the scoreboard, as we go through stages. How many stages were there? Correct, 5. There's 5 stages, and we'll see how many days it takes for this body to get to the pretty much unrecognizable, grotesque, look what I found, I got some bones stage. So here we go. We got those things are blowflies, which it's a great opportunity, too, to tell kids that maggots are actually larvae that turn into flies. So here's the body. That pink stuff is like odor kind of coming off the body. And on the TI Nspire, if you install the Smell-O-Vision app, you can actually smell. No, I'm kidding. You can't do it. Okay? But you can sort of see that that's the odor coming out. And watch the odor starts to kind of go away here as we get closer to the completed decomposition. And the scoreboard over on the right will stop eventually, but we are in the 40s here. Okay. And as we're doing that, let's take a look at the next page. And this is 53 days, okay? So it took 53 days to get from big guy with skin and flesh and tissue and organs and all that to basically skeletonized. Okay, now also take a look. We got some things that have happened to his fingers, and there's this black stuff is like residual dried up skin that's still on him. But this graph actually was being generated as the body was decomposing. So now the kid can go back here and say, to get to stage 2, that first stage took this many days, so that would be 5 days, here would be 10 days, here would be 15. So they can estimate how many days it took in each of the 5 stages to finally get to that last stage. And if they're not sure about that, they can just go over here to the spreadsheet where the data was actually filled in as the body was decomposing. So to get through stage 1, it takes 3.5 days, through stage 2, and so on. Okay, so that's the background. So we generate. You know, I told you I was going to do this again. Let's do Mike Ciminoville here. We're going to go hot and humid. So what do you guys think? You're going to predict here. When we were cool and humid, it took 53 days. How about hot and humid? Throw in your bets. Throw in your predictions. We're going to start it out, and we're going to see how long it takes this person in a hot, humid, Floridian Everglades environment to decompose. All right, I just had a bet thrown in there. It said half the time. Well, half of 53. Let's see what that would be. So, you know what I like? Okay, people are starting to say fewer days. Now, what if your student said that? Yeah, I predicted it would be fewer days. I'd be like running around hugging everybody. Because I'm like, exactly. Those environmental conditions are going to play a role in the decomposition rate, whether it's, like I said, a raccoon or a skunk on the side of the road, or a body that's been found in the field. So here we go, hot and humid. It took 12 days. Now check out the graph. And we have a much lower bars of yellow. So go ahead and make your prediction. I'm not going to run this one. But how about if we went cold and arid? Now here'd be a great opportunity. If you had TI Navigator, you could send out a question to your entire class using TI Navigator, and you'd say, how long do you think it will take? And they'd all respond, and you'd collect the answers, and you'd hold on to that until after the body is decomposed. So we're throwing out numbers here. But you know what they all were? Is either some people said a long time, or they're more than 53 or 54 days. And it actually is in the hundreds, I think, when you do that.
I love the visual there, Jeff. Especially with the bar graphs and everything on that page 1.14. That's just straightforward, great for students to see. It's really awesome.
I agree with that, Mike. And you know, when you talk about STEM, I always refer to it as this: in the acronym STEM, the ends of the acronym are most important. The science and the math are supported by the technology and the engineering piece. And so if we can bring science and math together and have them be seamless in these activities, that's what we're going for here. Yeah, I really like that too. There's multiple representations of the exact same thing. So here we have a visual movie, essentially, and here we have graphical and numerical data, and here we have just an overall average rates of decomposition. So yeah, I would agree with you on that, Mike. So then we throw in some questions that do have a right answer, and so they may have to go back to the beginning of the activity and check out, like, what were the conditions? And if you remember, they were warm and humid. I think it was the date was July. So let's jump ahead here because we want to make sure we get all of our activities taken care of. Oh, by the way, this is a question that I think is really interesting, and Dr. France actually schooled us on that. What likely happened to the fingers and the ribs? So the ribs are kind of, gone right in here. And if you know anything about anatomy, between the ribs and this sternum right here, there's a bunch of cartilage that allows your rib cage to be flexible. And if there's cartilage, that clearly is not bone, and that is much softer, and it's much tastier and easier to chew on than bone is. One set of bones that's very easy to chew on are fingers because they're very small and very narrow. And Dr. France said it's not uncommon at all to find a dead body and have this be happening. So there it is. Scavengers, like coyotes or whatever you would call them where you live, actually do come and start gnawing on the easy-to-get-to parts of the body. I know this is not, I'm not sure if you've eaten dinner yet or not, guys, but this is can be semi-disgusting.
Great for Halloween time.
It's, yeah, for Halloween time. Yeah, I don't think it's great for any time, but I learned one thing by helping with this activity. I know that a forensics anthropologist is not something that I was really cut out to do, because I don't know if I could handle the, oh yeah, it's been dead for 12 days and take a look at it kind of thing. I don't think I'd be cut out for that. So now, in the second simulation, this is exactly like the first one. Kids run it again, they get their data, but now they actually pay attention to the number of days, and what they do here is they replicate, there it is, they replicate the conditions that were found and were described at the beginning of the activity. So now they say, oh, they found this guy in July, it was warm and humid, they run it, and away we go. Yeah, some people are chatting like, you want to go out for ribs? No, thank you. I think I'll have tofu tonight. Thanks anyway. So there we go. There's the notes from the investigation. This is a fairly long activity, but July, warm and humid, and so on. And so now you're throwing, here you got the people again, who are our potential victims, and now we have little bubbles by them, and the idea is to choose based on the day it is, the condition of the body, and then do a little subtraction on the calendar with when did they disappear and what condition is their body in. The kids make a determination as to who they think the victim is. So this is the most exciting and engaging part of this, if you will, is probably watching that body decompose. The cool STEM piece of it is, like Mike said, showing those visual and multiple representations of the same thing. Okay, so here's a kind of a sum up, and it actually was this Cy Walker guy. So poor Cy, this dude right here, with the, here's your hint, mohawk. That guy was the guy that was found in the field. Let me see what else we have here. I don't think we have too much more. Now we just have some extensions. Okay, so let's move on to, I'm going to give you just a real quick description and go through a couple of quick things here with the activity that got the entire STEM Behind Hollywood thing rolling. It became wildly popular. Everywhere we show this, people love it. Kids love it. We've done I know Mike Cimino has actually done some workshops with the zombie theme. We actually have the help of a guy named Dr. Steven Schlossman on this. He is this is kind of weird, but he's a zombie expert, and he's a psychologist in the med school at Harvard, which is kind of even weirder, but he's a really normal guy and a really cool guy, and he helped us with this activity. And here's a couple things I just really love about it. The whole premise behind this zombie apocalypse is, this is plausible. This is, maybe zombies aren't, but the conditions that a zombie displays are clearly conditions that could be displayed if somebody had these parts of their brain sort of whacked. Okay, the cerebellum, the hypothalamus, the frontal lobe, and the amygdala. Most people have heard of the cerebellum. Most people have heard of the frontal lobe, hypothalamus. Some people, very few people have heard of the amygdala. But this is the fun one for kids. This is the part of the brain, sometimes it's called the crocodile part of the brain, which is basically, I'm ticked off all the time and I'm going to not stop until I kill you kind of thing. That's the amygdala. Now, again, look at the sneakiness here. We got color coding. If you look at the cerebellum over here, it's blue, and we color code it and so on. One of the beauties of TI Nspire CX is you can put things in color, and that's what's really cool about this. Just a thought, if you're in a STEAM school or a STEAM district, that A is arts, you could maybe say, and I don't know much about the STEAM programs, but you could say, hey, you know what we're going to do? Part of this is we're going to make a brain and use different color codings to mark the areas that would be affected by a zombie virus. Just a thought. You might want to jump on that a little bit. Okay, so here's our conditions of our zombies. Zombies are pretty clumsy. They just kind of shuffle around until World War Z came out, and then that kind of blew the whole thing out of the water. And now we have a cerebellum that's overdeveloped because those things are really fast. They have insatiable appetites. They have poor problem-solving skills. They just kind of shamble around. If you're like old like me in Night of the Living Dead and those old zombie movies, they really weren't much for thinking. And plus, they're not nice. They're just full of rage. Okay, all right. Now, you guys, do you see why I asked you to check out, was it Cy Walker or whatever? This is the guy right here, same guy. Poor guy is a zombie, and then he ends up being dead in the field. Well, let's just watch this guy. This is a real guy who graphically made up himself to look like this. And once you press play, it's a cycle. It just goes through all the different stages of the zombie virus. And just like every normal person, what you're probably drawn to first is the appearance of this poor guy's head and face. But if you let it run long enough, you start looking around the screen a little bit more, and you look over on the right and see the brain changing and the different parts of the brain either getting bigger and more pronounced, like in the middle with the hypothalamus and the amygdala, or the cerebellum and the frontal lobe of the cerebrum are just getting really atrophied. Okay, so that's the activity that kind of started it all. Then we have some graphical representations here of if a zombie virus did show up and it were contagious, this is the type of growth we would get, perhaps. Now, when we wrote this activity, it was far-fetched. Nowadays, with the Ebola scare and all the implications of that, this is a little bit realistic in terms of the spread of a disease through a population. There's another representation just taking, really minimizing this y-axis over here to make that the first few weeks actually look like there's some change. Okay, but this one's near and dear to our hearts, I know, because it was the very first one that we did. Let me just show you one more here. I'm going to make this thing crazy virulent. Virulent means just how nasty is this virus, and the max is 10. And the minimum, I think, is 0. So we're going to make this like a crazy, virulent virus. And just watch, again, this is what Mike was referring to in the body of evidence activity. I just click play. The red squares on the left-hand side are the zombies that are being zombified, if you will, and then it's being graphed in real time on the right. And you have the advantage on the computer software of actually seeing the comparison between normal humans who are dropping and zombies going up. And it's a great opportunity to say, hey, where do those lines cross? And where those cross, that's actually a solution in algebra for a system of equations and that type of thing. So there's all kinds of really cool things you can do with this. All right, Mike, I probably went over, but I'm going to pass this to you because I think it's cool for them to see one that they may not have seen, which is Zombie Apocalypse 2, which is we saved the day. We're going to take these poor zombies and hopefully cure them a little bit. So, Mike, it's all yours.
All right, thank you very much, Jeff. And what as Jeff said, we're now going to look at part 2, the humans strike back. So after this horrific zombie apocalypse occurred, what are the humans going to do about it? So again, and the current theme is, as you go through all of these simulations that we've shown you tonight, we start off with a scenario. And I'm not sure if you've ever, as Jeff was saying, I'm not sure if you ever read one of the books that Dr. Stephen Schultzman wrote, but it's called The Zombie Autopsies. And the one thing that I really like about this is it has a background story, much like that book, how it goes along looking at a journal of someone's research that they've done over a period of time. And it's really cool to look at it from that perspective. So we have the scenario here where zombies have overtaken much of the United States. The CDC has assembled a team, and they're trying to figure out a way that we can control this outbreak now that it's occurred. So we have our background information here, and we have the zombie virus inoculation task force, and Stephanie is considering a strategy that would likely decrease the ability of the virus to cause infection, or at least minimize it. So what we need to work on is a way to change the pH of the body. So it's affecting the pH, and we're going to see, is the internal pH of a living system, could changing that be harmful? And the students are going to go through and do a little bit of background research, and it sets them up and prepares them for the main simulation. So we've concluded here that it's possibly a prion rather than a virus that is causing this zombie outbreak. So we have this infected patient in holding, and there is our famous guy again with the mohawk. I want to kind of skip ahead to this part right here. So we have the background, and this is the notebook I was talking about before, how on December 8th, Dr. Stephanie Mann's notebook, she was trying to determine correct concentrations of a zombie drug design. So we're going to start with a basic titration, and I can't wait to show you this simulation here because it's brilliant. The beaker contains 50 mils of a 0.1 hydrochloric acid, and the burette contains 50 mils of a 0.2 molar sodium hydroxide. So we're going to actually, let's go in and actually check this out. So we're going to help Stephanie actually do the titration. She's performing the titration of a strong acid with a strong base, and she's using a simulation in the graph. She's going to determine the volume, and she's going to determine how pH is related to an excess of hydrogen ions or an excess of OH ions in a solution. So let's check this out. And there's a lot going on the screen here, but it's really cool. We have three main things. On the left-hand side, we have the TI Nspire with the experimental setup. And on the right-hand side, we have a picture of a graph, and we also have an up-close view of the beaker. Now we're going to press play here, just like as Jeff said earlier, to begin any simulation, we're going to press the play button. And right when we press that play button, you'll notice a few things. You'll see we're getting a pH reading, and you'll notice over here on the right-hand side, we have these different colored molecules over here. You have chlorine, you have the positively charged hydrogen. So we're going to actually add in a drop at a time. And as we're adding in a drop at a time, a couple things change here. You'll notice the pH on the left-hand side of the screen on the handheld is changing. You'll notice on the right-hand side, the colors inside the beaker are actually starting to change. And then you'll also see on the top right, you'll see a visual representation via graph over there showing how the pH is adjusting. We're just going to keep adding a couple drops in here. And all of a sudden, you see that color change. Now, while I'm doing this, on the next page, I'm also getting it plotted as a graph. So I'm getting that full graphical view of the data as I'm also completing the simulation. This is collected in real time. So as I'm going through the simulation and as I'm progressing through, it's going to collect the data on here. So if you don't have the materials to do an actual titration in the chemistry lab, we are doing it right here on your Nspire handheld, and every single student can work on it and do it. It continues to go on questions about what the contents of the beaker, and it wants them to go back and keep trying. We need to figure out where the equivalence point is. So the main goal is here, we need to create a drug that's going to get the body pH between 7.8 and 8.2. Anything different than that is going to result in being fatal. If I need to go back and redo the simulation, there's this little button on the top left here. It's the back button, and it's going to reset the simulation for me. And you'll also notice on the graph that data is gone again there. So once I start the simulation, it's going to replot that graph here. Yeah, I know I see a lot of comments about the molecular view. I absolutely love that. I love the visual, especially with the color. The kids are able to see exactly what's happening. And especially with the questions here. How many hydrogen ions are present in the beaker initially? So the students not only will see it in color, but they'll also, it gives them that easy to view visualization there. And it's very straightforward for the kids to see that. So we're going to continue going through as ask them about what's happening to the substance, what's happening to the molecules. And before I actually go on here, I want to show you something. One of the cool things about the TI Nspire is that I can actually input chemical equations into the TI Nspire. And I'm not sure how many of you have actually done that yet. So let's look at this one right here. Write a net ionic equation to show what happened to the positive hydrogen ions. So I'm going to show the handheld on the left-hand side here, so you can actually see what buttons that I'm hitting when I enter this in. So if I want to write an equation, I have my keypad down here. We'll put the H in for hydrogen. Now, we need to represent that little positive symbol there to show it's positively charged. So there's this the triangle key over here on the left, power of, we're going to hit that button, and then we're going to hit the positive symbol. And you'll notice there, it automatically gives that to me as a superscript there. So I'm able to do that directly on the handheld. Then when I hit the plus again, without hitting that the triangle over there, it's going to give me that, I'm going to be able to add another another pair of another compound there. And then if I want to show what it yields, I simply hit the equals sign. And of course, I would need to have the OH negative here, but I hit the yields, to get the yield, I hit the equals sign, and that shows that is how I can enter an equation into the Nspire, which is, I think it's a really cool thing. And this is a text match as well. It's a different type of question. So pretty much what I can do as a teacher is, if I have the Navigator system, it will automatically grade that for me based on if they put in the correct chemical equation. So it's just another, yeah, Jeff?
Sorry to interrupt you. Just type in, without any fancy, just type in H2O right now, just so they can see what you're doing. Just the letter H, and then he just typed the number 2, and it automatically subscripted it.
Yep. Thanks, Jeff. Yeah, that's a great feature. I love this feature on the Nspire. It's so intuitive. It automatically does it for you when you type in.
Sorry to interrupt you there, Mike. I just
no,
that.
Great. No, thank you. Yeah, no, definitely. Thank you. That's an absolutely outstanding feature that we have here. Okay, well, I'm actually running short on time, so there's a couple other things here I want to show you about the simulation. So we have another titration here where Stephanie's going to then experiment with a sodium bicarbonate solution. So what we need to do is determine what volume of bicarbonate would be needed to denature the prion and stop the epidemic. So the students, again, are going to use this simulation to try to figure that out. And you'll notice on the right-hand side here, we can actually zoom in on the prion, which is just another cool thing that we can look at here, get an up-close view of that prion as we increase the magnification. We press the play button, and we can, just like last time, we're going to be able to determine what volume is required. And it will let you know when you have denatured that prion. You then have the graph on the next page, and then it asks the students some questions. So, for example, do you think that this would be an effective way? Would this cure all of the zombies? What problems could you foresee from delivering this type of vaccination to everyone? Would infected zombies already recover? So if they were infected, would this cure them? So these are all the questions that you will be able to investigate. And one final thing I do want to show you is something that Jeff showed you last time. Instead of having infected humans, this time students are able to manipulate the dosage, and we are going to get to see a curing rate. If we had a dosage of 5, how many humans would we be able to save? If we had a dosage of 9, how many humans would we be able to save? I'm running a little short on time. Jeff, is there anything you'd like to sort of highlight or add in here, something I may have skipped?
Well, again, the cool thing that's embedded in all of these, and it isn't always called out, but it is at least kind of this covert thing, is STEM careers. I mean, not curing zombies isn't a specific STEM career, but epidemiology is a STEM career, vaccine development is a potential STEM career, research on how to take care of a major issue, like in this case, zombieism is a potential STEM career as well. So yeah, I like when we call out. Yeah,
it's just that hook. I mean, when I do this in the classroom and I say we're going to talk about zombies today, you have their interest. I mean, especially with the popularity of shows recently, like Walking Dead breaking records. When you're talking about zombies, you're going to get the students' interest right off the bat, and they're going to be listening. So that's the thing. I personally love the zombie simulations because my kids love the zombie simulations, and it piques. This is the hot topic right now. It really just piques their interest, and there's so much that can be learned through using this simulation. And Mike Houston, I think I'm going to pass the ball back to you here.